Steam Generation Boiler Part 2H. Thank you to watching Shoaib View channel. This is the last episode of Steam Generation Part 2. In last video I tried to explain the feed water system, fuel all system and ash handling system components. In this video I will try to explain on boiler safety and monitoring equipments. Safety valve. Many different types of safety valves are fitted to steam boiler plant, but generally they must all meet the following criteria. The SME Standard I and SME Standard 8 for boiler and pressure vessel applications, and the SME, an S1 PTC 25.3 standard for safety valves and relief valves provide the following definition. These standards set performance characteristics as well as defining the different types of safety valves that are used. SME1 valve, a safety relief valve conforming to the requirements of Section I of the SME Pressure Vessel Code for boiler applications, which will open within 3% overpressure and close within 4%. It will usually feature two blowdown rings and is identified by a National Board V stamp. SME8 valve, a safety relief valve conforming to the requirements of Section 8 of the SME Pressure Vessel Code for pressure vessel applications, which will open within 10% overpressure and close within 7%. Low lift safety valve, the actual position of the disc determines the discharge area of the valve. Full lift safety valve, the discharge area is not determined by the position of the disc. Full bore safety valve, a safety valve having no protrusions in the bore, and wherein the valve lifts to an extent sufficient for the minimum area at any section, at or below the seat, to become the controlling orifice. Conventional safety relief valve, the spring housing is vented to the discharge side, hence operational characteristics are directly affected by changes in the back pressure to the valve. Balanced safety relief valve, a balanced valve incorporates a means of minimizing the effect of back pressure on the operational characteristics of the valve. Pilot-operated pressure relief valve. The major relieving device is combined with, and is controlled by, a self-actuated auxiliary pressure relief device. Power-actuated safety relief valve, a pressure relief valve in which the major pressure relieving device is combined with, and controlled by, a device requiring an external source of energy. Instrumentation on boiler. Level measurement. Pressure measurement, flow measurement. Drum level gauge glass. The level of water in a steam boiler must be carefully controlled to ensure good quality steam is produced safely, efficiently and at the correct pressure. In most cases, the simple gauge glass on the steam, water drum or boiler shell is used as the indicator. Many standards stipulate the provision of two gauge glasses. Arrangements are usually required to prevent a breakage from causing a hazard to the operator. The most common form of protection is a toughened glass screen to the front and sides of the water gauge glass. Pressure measurement. Pressure gauges are used to determine steam pressure, feed water pressure, all pressure, gas pressure, draft pressure. Pressure may be recorded as gauge pressure or as absolute pressure. Gauge pressure is the pressure above that of the atmosphere. Absolute pressure is the pressure above zero pressure, equal to gauge pressure plus the atmospheric pressure. At sea level, atmospheric pressure is 14.7 psi. Pressure gauges include many pressure measurement devices including bellows, Bourdon tubes, capsule elements and diaphragm element gauges. Detailed form for analog or needle dial face gauges. Temperature measurement. Temperature gauges are used to determine feed water temperature, all temperature, water temperature, flue gas temperature. Temperature gauges can be classified as either mechanical in design or electronic. Mechanical temperature gauges include bimetallic or filled system design. A bimetallic thermometer uses two dissimilar metals joined together. Since these metals are not the same, their coefficient of expansion will be different, allowing the composite metal strip to bend in the direction of the metal with the lower coefficient. This is predictable and repeatable and therefore can be scaled. Bimetal temperature gauges are inexpensive and are commonly used in boiler applications. Fluid flow measurement. Fluid characteristics and flow theory, including Bernoulli's theorem and Reynolds numbers, are introduced and developed to provide basic metering theory and techniques. Different meter types, instrumentation and installation practice are also discussed. Flow measurement, fluid characteristics and flow theory, including Bernoulli's theorem and Reynolds numbers, are introduced and developed to provide basic metering theory and techniques. Different meter types, instrumentation and installation practice are also discussed. Many flow meters are based on the work of Daniel Bernoulli in the 1700s. Bernoulli's theorem relates to the steady flow energy equation SFE and states that the sum of pressure energy, kinetic energy and potential energy. Steam flow measurement. Most common method of steam metering is the traditional orifice and differential pressure transmitter technique. The main areas of concern with this type of measurement are the orifice plate's susceptibility to wear, introducing immediate inaccuracies, the relatively high pressure losses introduced into the system by the orifice plate, and the small, typically 3-to-1 measuring range. The other major issue with this approach is the number of potential emission points, which could be as high as 30 depending on the configuration adopted. Another significant area of potential inaccuracy is the DP transmitter itself. Even most so-called smart DP transmitters still utilize analog sensing systems. The primary analog sensor is very susceptible to drift caused by static pressures and high temperatures. These factors, coupled with the inaccuracies evident at low measuring ranges, can cause the overall performance of the metering installation to be highly suspect. Boiler combustion airflow measurement. Boiler airflow or airflow on a forced or balanced draft furnace may be measured with a pitot tube, airfoil section, or any calibrated flow restricting device located in the duct that leads from the forced draft fan to the wind box. The wind box is the area behind the burner throats that supplies combustion air to the burners. The differential across the wind box to the furnace can be as high as 25 inches H2O, but is not used because each time a register is adjusted, the flow relationship to delta P changes. On many boilers, airflow is the measured differential between the furnace inlet and the boiler outlet. This takes the differential of the hot gases as they flow through the furnace, across the convection section, and out the stack. In most cases, the differential ranges from 0.52 to 0.0 inches of water. Thank you for watching the steam generator part 1 and part 2. Next video, steam generator part 3, will be released soon, which cover boiler securities and efficiency and performance. If you like my channel, please subscribe and follow it. If you like my videos, kindly like and share it.